My name is Peter Ida. I'm a co-organizer of the Kubernetes London Meetup here, along with Ivan and Miloš. And you're probably wondering why I'm standing in front of you today. Just blame Miloš, because he's responsible for putting me up in front of you. So just endure me for the next 25, 30 minutes. I'll try to make this as snappy as possible. I also want to, just in case those of you that don't know Ivan, who was just speaking the last few minutes ago, he's joined us to co-organize this meetup, and we're happy to have him with us. Also, my son is here, seated over there. He helped me prepare this presentation. He's the youngest Kubernetes on the planet. So today, Kubernetes and stackstorm at Pearson. So as an introduction, so Pearson is almost 200 years old. There are a few companies that have been around for that long. It was started in 1844, and it actually started out as a construction company. And over the years, they've acquired so many other companies in various other industries. When you think about projects like the Blackwall Tunnel was built by Pearson. Some other companies that Pearson acquired include Financial Times, The Economist, Madame Tussauds, and many other companies that you've come across, but you probably would never have known that Pearson was behind it. So as a result of the length of time that Pearson has been in existence, in combination with the several organizations it's acquired, we have lots of legacy issues. So legacy is the name of the game at Pearson. In the last few years, Pearson rebranded and refocused as an education provider, and is currently providing services to about 75 million learners in 70 countries. We have over 400 development groups, not 400 developers, but actual 400 development groups. We have an ambitious plan to reach 200 million learners in the next 10 years. And for us to be able to achieve that objective, a platform was needed. We needed to build a platform that could scale to meet the demands of the growing online audience. So at Pearson, the Bite-Size project is actually the new platform, and it's built on Kubernetes. And today's discussion will just focus on how we extend Kubernetes to be able to support our various other components on the PaaS. My colleague called Mike Ward, he's our lead architect, he's based in Denver. He spoke briefly, giving an overview of what we do at Pearson at KubeCon this year. And, oops, what's happened? Okay. Yeah, it's just taking a few seconds. Okay. Okay, so today's discussion will basically be talking about what we do with Kubernetes and extensions via third-party resources and stackstorm. So as I was saying, my colleague did give an overview at KubeCon. If you search Skills Matter, you'd probably find the videos. And then my other colleague, Martin, did a demo or a presentation here in May, this same venue, talking about how we implement Consul and Vault at Pearson. So Kubernetes provides us with some awesome primitives to build a PaaS. And we've had, last year we had someone from Red Hat talk about OpenShift. I don't know how many of us were here when James Strachan was just saying, and Kubernetes is freaking awesome. He was very animated about it. And we had Gabriel Monroy earlier this year talk about how they build their PaaS in days. And we also have some of the folks like Rimas, I don't know if Rimas is here today, talking about what they do at days. And the reason why you can build a PaaS on top of Kubernetes is because of the resources that you have available, like pods, ingresses, daemon sets, pet sets, replica sets, and all the sets. I don't know why everything is called a set. Anyway, you have jobs and other things. And all these things are very helpful when you're building a PaaS. Now, the nice thing about these is all the resources are exposed and driven by the API. So you don't have to do any, roundabout. You don't have to start looking about where you're going to extend stuff or you're going to use stuff. Everything is exposed at the API level. Now, having said that, sometimes you need extra functionality on the PaaS, and those functionality might not be available in Kubernetes at the point in time. So for example, when we wanted to integrate stateful services, we didn't have pet sets available at the time, so we had to find a way out to be able to add specific functionality upon Kubernetes. And the nice thing about Kubernetes is that it's really very easy to be able to extend it. You can do it pretty easily, and I'll show you briefly. Hopefully the demo will work today. So now the question is, what do you do when you need a resource type that is not available in Kubernetes? And this could be, it's because it's a feature that hasn't yet been built. It's probably still being worked on upstream. Or it could just be a custom type that you need for your own project. Just for whatever reason, it's not available in Kubernetes. What do you do? So, educate yourself. You don't have to hit your head on the wall or reach out for your favorite bash shell script quickly. There are many ways to go about this, and hopefully at the end of today's talk, we'll be able to see one of the ways you can do this in Kubernetes. So, if you want to extend Kubernetes, what you can use is a third-party resource object type. Third-party resource objects are simply a way to extend the Kubernetes API with a new API object type. And when you create a new third-party resource object type, an endpoint URL will be generated for you. And at that endpoint URL, your normal CRUD operations are supported, so you can create resources there. You can read resources, update, and delete. All the stuff you can do in any of the other object types. The things you can do like on a pod, or on an ingress, or on the daemon sets, all the API functionality that's exposed, you have similar available with third-party resource object types. Now, I should say that third-party resources are currently in beta, but we've been using them for about maybe 10 months or so, and we found them relatively stable enough for our purposes. But I'll encourage you to play with it a bit if you haven't played with it. I know a number of people here have done much more than this, but for those of you who haven't, it's something that you can play with, and to be able to do that, you'd need to pass a runtime config, which would enable third-party resources on your API server, because it's not enabled by default. One other thing I should say is that because the third-party resource object types objects are basically compatible with basically compatible with your Kubernetes classic objects, and therefore things like watching, you can watch those endpoints, and this is very key for how we hook various other things into Kubernetes, and we'll see that later. So this is an example of a Kubernetes third-party resource type, and over there on the left you see we have API version, its extension /v1 beta 1, and the kind is third-party resource. And under the metadata section, you have the name, and the first part, MySQL, is actually the name of the third-party resource type. Pearson.io is just it could be any domain name extension you want, and that part of it is what will now be referenced later on as the API group name. Below it, you have the versions, and here we just have v1. So if you hit that endpoint, you have it generates a friendly URL which you can use to just manage your resources. So on the /APIs, you have Pearson.io, which is the domain name extension you had, which is now your API group, and v1 is now the version. So over there, you can see the group version, Pearson.io /v1. So whenever you create a Kubernetes third-party resource type with the YAML file just like that, this is what gets generated. Once you've created your third-party resource type, the next thing is you need to create custom objects. Now, think of the third-party resource object type we saw in the previous slide as the schema for your database table. And the custom objects are like, populating rows in the table of your database. Another way to look at it is to think about it from an object-oriented programming paradigm. So you could say that the third-party resource type is like a class, and the third-party resource custom objects are like instances of that class. So, and it's really very useful if you want to store custom data in etcd, for example. etcd is a distributed data store that backs the Kubernetes itself, and sometimes you want to put stuff in it. And one of the ways you could do it is using third-party resources, because it provides a very easy way for you to be able to store anything you want, really, in the API or in etcd via the API. And now this is an example of the third-party resource custom object. We call this particular one, we call maybe the name, under metadata, we call it the name AwesomeDB. We have a namespace called demo, and you have your API version. And if you look at the API version this time around, it's referencing the group version that we just created earlier on in the slide where we talked about the third-party resource custom type. And when you hit the endpoint here, where we have api/pearson.io/v1/MySQLs, it will now give you all the custom, it will now list all the custom objects that you've created at that third-party resource object type endpoint. And that's pretty much it. With those two YAML files, we've been able to extend the Kubernetes API, and we can now do lots of interesting stuff with that. I'm not aware of any other tool in this space that makes it that easy to extend the API to add extra functionality. And when you think of a resource type like the network policy, I don't know if anybody has used like Calico or Flannel or all those other good stuff. All those things, well, I know of Calico definitely. Calico implements the network policy type that was introduced in Kubernetes 1.3. But before then, it started out as a third-party resource type. So if you're prototyping something that you're hoping to submit upstream, or something that you're hoping that would eventually get into the API, you can start from a third-party resource object type, and then later progress until it becomes its own native object. And the nice thing about it is once you create your third-party resource objects, you can manage them with your favorite kubectl commands. So, for example, the first YAML file for the third-party resource object type, you can create it, and you can see there the third-party resource is created. Then under it, you have the AwesomeDB YAML, which is an example of the of a third-party resource custom object. And after you've created those two objects, the next thing you have is you can start managing it with your kubectl get command. And under it, you can see that we can directly manage a MySQL object. It's actually a first-class citizen, as you have pods or ingresses or any other resource that you'd like to manage. And that's really it, with just those two YAML files. And so when we were thinking of extending Kubernetes in the bite-sized paths, we were thinking it might be a bit difficult for us to start integrating every single tool one by one into third-party resources. So we started looking around for a tool that could do two things for us. On one hand, a tool that would integrate with Kubernetes third-party resources over here, and at the same time would be able to integrate all the tools we'd like to integrate with Kubernetes. So a single tool that will, on one hand, integrate with third-party resources, and on the other hand, it could pull in things like Console, Vault, could send notifications via HipChat or Slack, whatever it is, make REST API calls to AWS resources, anything you wanted to do. And that is how we stumbled on stackstorm. And stackstorm is an open source event-driven automation tool, which was acquired earlier this year by a company called Brocade. And it's used pretty heavily, well, I'm not sure, I won't say pretty heavily, but it's used quite extensively at Netflix. And they had a blog post that came out, I think, sometime in August, in August, where they described how they built their event-driven automation tool based on stackstorm. And it's an interesting post to have a look, so please do have a look at it later on. So now, stackstorm for us provides a single entry point to extend Kubernetes. For us at the time, there wasn't any pet sets, so we were looking for a way to bring in things like RDS, Mongo, our stateful services to be part of the PaaS natively. And this was the route we took to bring this into the PaaS. It also provides integration for us for things like CloudFormation, Elasticsearch, and Console, Vault, handles credential setup, blah, blah, blah. It does all those for us. The other thing that we use it to do is it provides a single interface for us to run common operations tasks. So now, at Pearson, because we're such a large organization, you have various operations staff at various levels of skill, requiring various levels of authorization to do various tasks. So we weren't comfortable with giving everybody access to the kubectl interface to begin to run things they want to do. So stackstorm comes with a nice web user interface where we can define the actions that we allow our operations folks to be able to do. It also is an entry point for our customers to interact with the PaaS. And it also provides a consistent interface for our developers who want to write tools against the PaaS. So for example, if we woke up one morning and say, we don't want to use console anymore, we want to use something else, the latest fad in the market, they wouldn't have to change the tool that they're using to integrate with the PaaS, because we're only exposing a consistent interface, which is stackstorm in our case, and it provides a nice API so you can build tools against it. So, a few stackstorm concepts. You have the concept of a sensor, and a sensor is simply a Python adapter. It provides a way to integrate an external system. So what we simply do is, like we saw in the previous slides, the third-party resource object type endpoint, we configure it, we set that in the sensor. So the sensor continually watches that endpoint. And in our case, we're only using, we're only watching for events like the added or deleted. Kubernetes supports watching for modified or for error, but we're only interested in added or deleted, at least so far. Then once the sensor detects any changes at the endpoint, the next thing is you have a trigger. And the trigger is simply an internal representation of the data that it captured from the Kubernetes third-party resource object type endpoint. When a sensor catches an interesting event, it just fires a trigger. And the rules, we have another concept in stackstorm called the rules. And all the rule does is it really ties all the data that was captured via sensors and triggers to stackstorm actions. So stackstorm actions, these are outbound integrations. Anything that's interesting to us. It could be running scripts, it could be REST API calls, sending notifications, logging into external systems, whatever it is what we refer to them in stackstorm as actions. And the nice thing is you can tie or chain several actions together. So you can have an action that builds a system, and after the system is built, you have another action that sends a notification. Now, this is an example of a YAML file that chains actions together. Everything is YAML these days. We just do YAML engineering. And so stackstorm is another case, a typical case of you express everything your actions as YAML files. And in the first one, you have, the first action is called name dbrds spec, And in this case, all it's doing is capturing the payload it received from the Kubernetes third-party resource type endpoint. And the next action is simply deleting the database. So tying it together, it's very simple. You have the Kubernetes third-party resource object type endpoint, which we're watching with our sensor. And immediately there is any activity, it fires a trigger within stackstorm. And the trigger object itself contains the Kubernetes third-party resource metadata. And once you have the trigger, the next step is the trigger trips the rules. You can define rules, and the rules check the trigger object against its criteria. If there's a match, it runs an action or a chain of actions, which we also call workflow. So now this is an example stackstorm rule file. And in this case, the name is Kubernetes RDS create at the top. Then we have a trigger, which is simply the Kubernetes third-party resource object. And our criteria checks this trigger object, and it's looking to see if it contains the string added. If it detects the string added, then you now have the next trigger.object underscore kind, which is basically checking to see if the key object underscore kind is equal to MySQL. It's basically a dictionary or a map, whatever you want to call it. That's what the object looks like. And stackstorm delivers all of its code as it's something called a pack. So they're just like pluggable batteries, and they simplify the management and sharing of stackstorm functionality. You currently have over 60 packs contributed and maintained by the open source community. You have packs for well, not everything, but a lot of the common tools that you want to use. And there is, interestingly, also a pack for Tesla. So if you are feeling very nifty and you decide that once you've done your deployment and you want your car to give your Tesla to give you a notification, you actually have a pack to integrate that. Once I buy a Tesla and I actually test it, I'll come back and give a demo and show you what it looks like. So, and the Stackstorm Kubernetes pack was contributed by Pearson, bite-sized team. The current development is available here. And you have other resources. Talk more about that in these links here. So, just to give a brief demo of what we could possibly do with this, if I log into the Kubernetes master here, I hope this demo works today. Oh God. Okay, so here we have the MySQL. This is a third-party resource object type. I don't know if you can see it. Maybe I make it larger. Okay, let's clear this. Okay, so that's a bit better. So that's the example of the MySQL third-party resource object type. And if I do, so you have with the kubectl command, you can see these are the two third-party resource object types I've created. I did that earlier, and that's exactly what I used to do that. And if I hop to the console, if I can, okay. Let me exit this. And if I hop to the console, right, so we have no RDS instances available here at the moment, which is exactly what we want. And then if I have a look at our awesome DB, sorry, I need to bring that up a little bit. So this is the awesome DB definition we had early on. And we should be able to create this, and hopefully this would work. So if I do this, we should ideally find instances created. Not yet. Okay. I think there's something to do with my network connection here. Stir. Okay, so basically with the kubectl command, you can see that simply using your native kubectl commands, we just created an RDS instance. This would take about 20 minutes, and once it's finished, we have a chain of actions that would run. One of the things that it would do is it would take the URL connection string that you use to connect to RDS. We store it in console. Then the password which we generate as part of our action workflow, we store it in Vault. Once all those are stored there, then this would finish. But we can't wait for this. But this is essentially one of the things you can do, which is just really the tip of the iceberg. We use it for Mongo, we use it for Elasticsearch services, we use it for console, we use it for various other things, and you can chain the actions together and send notifications. But that's just briefly what you can do with stackstorm. And that brings me to the end of my talk and the demo. Thank you very much. Any questions? Okay, Ilya.
Thanks so much. This is a really interesting use case for the third-party resource API, I think. I haven't seen more interesting things being done with it so far. Yeah, so, well, it sounds like there are quite a few pieces you still had to put together, right? The stackstorm helped you out with that, but then there's still a few things that you had to do yourself. So could you sort of briefly describe how many different bits there are? I don't know, whether it's lines of code or different like microservices that implement this?
Okay. Yes, I can go into more details as to exactly how we did it. The reason why I didn't go into all of that was because of the time, but let me try to show you a bit more. So if I hop onto the stackstorm instance itself, and here you have your sensors, and if I go to sensors, you'd see stackstorm is written in Python, so it was one of the reasons why we chose it on the team, because there were a number of people that were comfortable with Python. So if I look at the MySQL resource.py file, this is basically the definition we have for MySQL, but the actual generic third-party resource sensor base we have here. So this is the sensor itself, or where we define our own sensor and where we point to the Kubernetes API endpoint if we find interesting. We're using basic auth in Kubernetes for our config, so we're using user, password, blah, 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 to authenticate against Kubernetes. And the trigger is also defined here. And then once the trigger is defined, it fires off to, it triggers, once the trigger is defined, it trips up the rules, and I can show you the rules section here. We have, let's have a look at the it's open, RDS. Yep, so this is the RDS definition, which we're using, and you can see here where it says you can check the pattern, and once you find the added string there, it would create the resource and also check if the pattern equals to it. You can define as many criteria as you want. The other thing that I probably didn't mention is there is also a Kubernetes API client that is part of this pack, and which is what we use when we are either making changes via the web user interface or via the API. That's what we use to interface with Kubernetes. And every single pack, whether it's a pack for Tesla or a pack for console, or each pack comes with an API client, which is what each pack uses to be able to communicate with the service it's trying to support. I don't know if I'm answering questions or going in the wrong direction, but I could probably ramble around this from here till the end of the day. I don't know if my colleague here is here, Andy. Is Andy here? Okay, I can't see him. So yeah, he was going to be here. I mean, after the meeting, if you want to talk about it a bit more, we can talk about it. But that is basically it. There's really the reason, and this is one of the reasons why we chose it, because it was really lightweight. All you need is a tool that watches the Kubernetes third-party resource endpoint. It doesn't have to be stackstorm. You just need something that watches for changes, and once a change is detected, you need to be able to run any set of tasks as long as some certain rules are defined and you meet the criteria. Anything you want to run, you can run. It works pretty nicely for our purposes. Any other questions? Yes.
Have you managed to Dockerize or put stackstorm under Kubernetes itself?
That's an interesting question, because I can actually see the Jira task in the office right now sitting there. So that's why I'm laughing. The reason why, at the moment, it's not Dockerized, as in we're not using the Dockerized version, and it's because before Stackstorm got acquired, we were making a lot of progress, but once they got acquired, I think we lost the focus of the development team changed a bit, and we are just now beginning to see again if the Dockerized version of Stackstorm actually works now. It wasn't really working before. It was a pain, and we don't really have the time to fix it for them. We have had to fix a number of things, and we have submitted a number of patches upstream. But we're hoping that we'll be able to use the Dockerized version, because it would really make the experience much, much smoother, because we've had to do a lot of workarounds to make Stackstorm behave more natively within Kubernetes. But once it's delivered once it's Dockerized, it can just sit on Kubernetes like every other thing on the PaaS at the moment. I hope I answered your question. Any other thing? Thank you very much for listening to me.